All right, open up your book to section 5-4. We're on page 261 in your book. And the title of this section is the values of the 6 trigonometric functions, which might take you back for a second and think that maybe perhaps there's an error there in that slide. You might go, wait a minute, there's only 3 of those. That's not the case. There are actually 6 of these. You've only been introduced to 3 of them in your previous courses, though. So we're going to learn the other 3 on top of the 3 that you already know here. The objective then is to be able to find the values of the 6 trig functions approximately by using a calculator for any angle and exactly for certain special angles. We'll deal with the special angles here in the second half of this section. All right, let's start out with your 6 trig functions. Actually, we're going to look at 3 of them to start off with, the 3 that you know. 2 of these we already looked at in the last section there, so we should be comfortable with this idea of sine and cosine, and that we're extending beyond the idea of just working with angles that fall in a right triangle, where I would be limited to only working with angles that are between 0 and 180 degrees. I want to go beyond that, so we put a point UV in the coordinate system there. We mark our terminal side for some angle theta that we're measuring. We're marking this angle in standard position. And it turns out that the sine of theta is equal to V over R. The cosine of theta is equal to U over R. Again, that hopefully is just a little refresher there for us from the previous section. Now, for tangent. Tangent we have not defined in this way. Tangent we know is in terms of the SOHCAHTOA. TOA being the tangent is the opposite over the adjacent side. The opposite here is that value of V. The adjacent is the value of U. So tangent of theta is equal to V over U. And of course, if you know the point UV, you can always calculate R. R is just simply the square root of U squared plus V squared, and that is always a positive value. It's a positive number. All right, so there's what we know for sine, cosine, and tangent. In fact, we didn't talk about tangent, like I said in the previous section, but based on our discussion there, you probably could have come up with this fact here, that tangent of theta must be equal to V over U. All right. What are these other 3 trig functions we're talking about? Well, it turns out that if we take the reciprocal of these 3 functions here, the reciprocal of sine, the reciprocal of cosine, and the reciprocal of tangent, those turn out to be the other 3 trig functions that we define. Now that turns out to be a consequence of the way we really define them, but we won't get to that formal definition until a later chapter. But for right now, if we understand that it turns out that the reciprocals of these 3 trig functions that we know give us the other 3, that'll be all we need to know in order to define these 3 new ones. So here we go. You have a function called cosecant. Cosecant is how you pronounce that. We abbreviate that CSC for cosecant. Notice that we don't abbreviate it COS because we already have one called cosine that's that abbreviation. So CSC is for cosecant. COS is for cosine. And it turns out that cosecant is the reciprocal of sine. So I could write cosecant of theta is equal to 1 over the sine of theta. And since I know that sine of theta is equal to V over R, that means that cosecant of theta must be equal to the reciprocal of that, which would be R over V. We have another function called secant. Secant of theta is the reciprocal of cosine of theta. So since cosine of theta is equal to U over R, that means that the reciprocal of that would give us R over U. Secant of theta turns out to be R over U, or that's the reciprocal of cosine. And finally, the last one there is the cotangent function, which we abbreviate COT. So cotangent of theta is equal to the reciprocal of tangent of theta. And since tangent of theta we said was equal to V over U, the reciprocal of that would be U over V. So cotangent of theta is equal to u over v. So there we go. Those are our three new trig functions. We have cosecant, CSC, secant, SEC, and cotangent, COT. Make up our three new trig functions. You'll notice there, by the way, that these show up with in kind of pairs. You have sine and cosine. You have secant and cosecant. And you have tangent and you have cotangent. There's a reason that those names are picked, and there's the reason that we give them those names. That's a discussion for a later time. We'll come back to that idea and we'll actually see the real definition of each of these trig functions. It just turns out that this is kind of a consequence of the definition that we have for each of those trig functions, that they are reciprocals of these other three. All right, so let's take a look at a couple of examples here. If you look at example 1 there on page 264 in your book, example 1 says, evaluate by calculator the 6 trig values of 58.6 degrees and round to 4 decimal places. All right, so I'm going to define this. They didn't call it theta, but I'm going to go ahead and do it that way and say theta is equal to 58.6 degrees. And that way I can just simply use theta here as I write this out. That what they're asking us to find here is what the sine of theta is equal to, what the cosine of theta is equal to, and what the tangent of theta is equal to. All right, and then we'll deal with those three first, and then we'll deal with the reciprocals or the other three trig functions in just a second. So grab your calculator. All right, so with your calculator then, you got to make sure that you are in degree mode. If you're not in degree mode, go to your mode menu and switch over to degree down here from radian to degree. And we want to evaluate each of these trig functions at 58.6 degrees was the number they gave us here. So we're going to take the sine of 58.6, and I'll take the cosine of 58.6, and finally the tangent of 58.6. All right, and I'm just going to grab a picture of that. I'll copy that and I'll put that in here, and we'll write down each of those values that we came up with here. All right, so starting with the sine of 58.6 degrees there, it was 0.854, I guess, if we round that to 3 decimal places. I know the book said to go to 4 there. You can if you want to, but again, I'm only going to require that you have 3 decimal places. Cosine of 58.6 was 0.521. 0.521. And the tangent is 1.638. 1.638. There we go. Now, if you want to calculate the other three, you're going to be looking on your calculator for a long time if you're looking for a button that's called secant or cosecant or cotangent. They're not there. So instead what we have to do is use our reciprocal properties to come up with those. So we can do that. Let's switch back over to our calculator here. And what I want to calculate then, let's start with cosecant. Cosecant I know is the reciprocal of sine, so that's 1 divided by the sine of 58.6. Again, you don't have a cosecant button on your calculator, so you can't just type in the cosecant of 58.6. Let's do secant next. Secant is the reciprocal of cosine, so 1 divided by the cosine of 58.6 will give me the secant of 58.6 degrees. And finally, for cotangent, cotangent's the reciprocal of tangent. So if I take 1 over the tangent of 58.6, that gives me the cotangent of 58.6 degrees. Let me grab a snapshot of that. And we'll paste it onto our slide here. All right, and let's go ahead and write those ones down. All right, so the cosecant of theta of 58.6 degrees turned out to be 1.172. The secant of 58.6 degrees, or the secant of theta here, is 1.172. 919. And finally, the cotangent, the cotangent of theta, or cotangent of 58.6, was 0.610. There we go. There are our 6 trig functions evaluated at 58.6 degrees. Again, you have 3 of those buttons there on your calculator to evaluate those. And to evaluate the reciprocal, you take 1 divided by each of those to come up with the other 3 trig functions, since they are defined as reciprocals of these other 3. All right, take a look at example 2. Example 2 says if you know a point on the terminal side of an angle, sorry, I'm reading the wrong part here. So example 2 says the terminal side of angle theta contains the point -5, 2. Find exact values of the 6 trig functions of theta and use radicals if necessary, but no decimals. Okay, so let's write this point that they gave us. In fact, we're going to go ahead and sketch this in a second here, but they gave us the point -5, 2. And it says that point is on the terminal side of an angle theta, and they want us to find the exact values of the 6 trig functions. All right, so let's mark this. At -5 will be here. We'll say that this is 2, so we'll draw ourselves an angle that goes through this point right here. So again, this point right here is at -5, 2. That right there is my u and my v. In order to come up with my 6 trig functions, I need to also find out what r is equal to. But we know how to calculate r. R is just the square root of u squared. That's a -5 squared, plus v squared, which is 2 squared. So 25 and 4, that sounds like 9. So the square root of, it's 29. Square root of 29 is our value for r. So this is the square root of 29. If you want to write it on there, you can on the graph there. All right, so that's all I need in order to come up with my 6 trig functions. I'm going to kind of split this into 2 sets here of values that I'm going to write down. Let's deal with the 3 trig functions we know really well. That is the, let's start with sine actually. It really doesn't matter, but I think they try to stick with sine here on a regular basis. So I'll say sine of theta, and I guess I should define up here in my sketch what theta is. I'm calling theta this angle here. They don't really tell me much about theta, so I really don't know if theta is a positive or a negative angle. I don't know if it's between 0, 360 or not, but I can mark that at least, that angle is theta here that would have this point on the terminal side. And theta, sine of theta I know is equal to v over r, so that's 2 divided by the square root of 29. And now for the cosine of theta I know is equal to u over r, so that's a -5 over the square root of 29. And finally, the tangent of theta is equal to v over u, and v again is 2, and u is equal to -5, so that's 2 over a -5. And now, if I want to find the other 3, really all I have to do is reciprocate these 3 right here. So I'm going to just write those kind of right next to them here, and I'll write the reciprocals that correspond to each one of these. The reciprocal of sine is cosecant, so cosecant of theta is just the reciprocal of this. So just take and flip that over there. So we got square root of 29 over 2. And the reciprocal of cosine is secant, so that's equal to the square root of 29 over a -5. And finally, the reciprocal of tangent is cotangent, and that's equal to a -5 over 2. And that right there is the values of all 6 of our trig functions if the terminal side of our angle goes to that point of -5, 2. All right, and that's the end of the first part here of section 5-4.